In this video, we'll discuss 3 examples on how to simplify compound fractions. So a compound fraction is a fraction within a fraction. And in this example, we have 1 plus 4 over y minus 2 divided by 2 minus y. So I would like to focus on this division in the second term. So I'll have 1 plus, and I'm going to place 4 over y minus 2 within a bracket. And I'll change this fraction here into division. And I'm dividing 4y minus 2 by 2 minus y. Now notice that 2 minus y is the same as saying 2 minus y over 1. So when I continue, I will now focus within our first bracket which we have created. And I will create a single fraction. So my lowest common denominator would be y. And in the first term, I do not need to manipulate the numerator or the denominator to get to y. But in the second term, I have 2 over 1. And when I add a y, I need to multiply 2 with y as well. So it will be 4 minus 2y. And I close the brackets. Then I will apply the tip and times rule to change this division into multiplication. And that will lead to multiplying by 1 over 2 minus y. So now I notice that these fractions are starting to look very similar. But in the numerator in my first fraction, I can take out a common factor of 2. So when I do that, it will lead to 1 plus 2 times 2 minus y over y, closing the bracket, multiplied by 1 over 2 minus y. I notice that I have similar terms which will cancel one another out. And that leads to a simplified fraction of 1 plus 2 over y, because we have 2 over y multiplied with 1. Now we have quite a simplified answer, but when we simplify fractions, we want to leave it as one fraction. So again and again, I'll create a lowest common denominator of y. And that means that the first 1 would change into y, and the second term would simply be plus 2. And now we have our final answer. In our second example, we have 2 plus 15 divided by 2 plus 15 divided by 2 plus 15 divided by 2, and so forth. So that pattern continues indefinitely. So in order to solve this algebraic fraction, let us set this whole system equals to x. So we let x be equal to the system of fractions. That will mean that x is equal to 2 plus 15 over x again. So notice that if I replace this denominator by x, it will also continue indefinitely. So I have 2 plus 15 over x in total. Now it's easy for me to solve or find the value of x. What I'll do in this equation is I'll multiply everywhere by x in order to remove this fraction. And that will lead to x squared is equal to 2x plus 15. And when I simplify further, I have x squared minus 2x minus 15 equal to 0. And when I factorize that trinomial, I have x plus 3 times x minus 5. And that leads to a solution of x equal to 5. And I can consider x equal to negative 3. But this fraction would never yield a negative answer because I continuously add onto it. So x will not be equal to negative 3. And therefore, if this fraction or system continues indefinitely, it will be equal to 5. In our third example, we have 1 over 5 times 2 over 3 plus 1 over 5 times 2 over 3 plus 1 over 5 times 2 over 3, and that system continues indefinitely. So again, let us set that whole system equal to x. Therefore, x would be equal to 1 over 5 times 2 over 3 plus x. So when I ignore the first system, I see that the remainder is still equal to x. And that is why I can rewrite it as 1 over 5 times 2 over 3 plus x. Now let us find the value of x. So first I will multiply everywhere by 5, and that will lead to 5x equals to 2 over 3 plus x. Next I'll multiply by 3 to get rid of this fraction, and that will be 15x is equal to 2 plus 3x. And when I simplify that, I have 12x equal to 2. And when I solve for x, I have x is equals to 2 over 12 or 1 over 6. So this system, if it continues indefinitely, would be equal to 1 over 6.